Welcome to Mind Tier Learning, where we make GCSE learning and revision easy. This lesson is about taking the algebra skills you already know and applying them to more complex problems, including equations with fractions, rearranging formulae, and translating worded problems into algebra. These skills are especially important for GCSE exam questions, because they often test whether you can choose the right method, not just follow a simple one-step process. Before we begin, remember to like this video, subscribe to Mind Tier Learning, and follow along carefully. By the end of this lesson, you should be able to solve equations with complex fractions and denominators. You will also be able to change the subject of a formula, which means rearranging a formula so that a different variable is on its own. You will practice translating worded problems into algebraic equations or inequalities. Finally, you will apply these techniques to GCSE-style exam questions. The key idea today is that complex algebra becomes much easier when we break it into clear steps. Let's start with the key vocabulary. A formula is a mathematical rule showing the relationship between different quantities. The subject of a formula is the single variable being defined. For example, in v equals u plus at, v is the subject. A rearrangement is the process of moving terms around in an equation to isolate a specific variable. An expression is a group of terms made from numbers and letters without an equal sign. These words are important because rearranging formulae depends on understanding exactly what each part of the algebra is doing. Before we move into complex algebra, let's quickly recap number lines for inequalities. A solid circle means the value is included. This is used with less than or equal to or greater than or equal to. An open circle means the value is not included. This is used with less than or greater than. The direction of the arrow also matters. If the arrow points right, x is greater than the value. If the arrow points left, x is less than the value. Think of a number line as a map showing all the possible solutions. Let's do a quick knowledge check. Question 1. What does a solid circle on a number line represent? Question 2. Is 3x plus 5 an equation or an expression? Question 3. Solve 2, x minus 4 is greater than 10. Pause the video and try all three before checking the answers. Let's check the answers. For question 1, a solid circle means the value is included. This happens with greater than or equal to or less than or equal to. For question 2, 3x plus 5 is an expression because it has no equal sign. For question 3, start with 2, x minus 4 is greater than 10. Add 4 to both sides. That gives 2x is greater than 14. Divide by 2. So x is greater than 7. Fractions can make equations look intimidating, but the main strategy is to clear the denominator. That means we multiply every term by the denominator. For example, x plus 4 over 3 equals 5. To get rid of the denominator 3, multiply both sides by 3. That leaves x plus 4 equals 15. Then subtract 4 from both sides, so x equals 11. The important point is this. If you multiply one side by the denominator, you must multiply the whole other side too. Sometimes equations have different denominators. When this happens, we find the lowest common multiple, or LCM, of the denominators. Look at the example. X over 2 plus x over 3 equals 10. The denominators are 2 and 3. The lowest common multiple of 2 and 3 is 6. So we multiply every term by 6. X over 2 times 6 becomes 3x. X over 3 times 6 becomes 2x. 10 times 6 becomes 60. So we get 3x plus 2, x equals 60. That simplifies to 5x equals 60. Divide by 5 and x equals 12. Now, let's practice clearing fractions. To solve 2x over 5 minus 1 equals 3, we first multiply all terms by what number? Then, we need to complete the equation and solve for x. Use the word bank to help you fill in the blanks. Pause the video and have a go before checking the answer. Remember, because the denominator is 5, multiplying everything by 5 will clear the fraction. The completed solution is, to solve 2x over 5 minus 1 equals 3, we first multiply all terms by 5. That gives 2x minus 5 equals 15. Then we add 5 to both sides, so 2x equals 20. Finally, divide by 2. X equals 10. The key step was multiplying every term by 5, not just the fraction. Now, let's look at changing the subject of a formula. Changing the subject means rearranging a formula so that a different variable is on its own. Think of rearranging as unwrapping a formula. We use inverse operations to isolate the variable we want. If there are fractions, we eliminate them by multiplying by the denominator. Then, we isolate the term containing the subject by adding or subtracting. Finally, if the subject has a coefficient, we divide by that coefficient. The goal is to get the chosen variable completely on its own. Now, let's look at a more advanced rearrangement. Sometimes the subject appears more than once. For example, make x the subject of ax plus b equals cx plus d. First, get all the x terms on one side. Subtract cx from both sides and subtract b from both sides. That gives ax minus cx equals d minus b. Now x appears in both terms on the left, so we factorise. X bracket a minus c bracket equals d minus b. Finally, divide both sides by a minus c. So x equals d minus b over a minus c. The key step here is factorising when the subject appears in more than one term. Real-world maths does not always arrive as a neat equation. Often, it comes as a story. To translate worded problems into algebra, look carefully for keywords. The word often means equals. The word sum means add. The word product means multiply. The phrase at most means less than or equal to. For example, a taxi charges £3 plus £2 per mile. My total is at most £15. Let m represent the number of miles. The algebraic inequality is 3 plus 2m is less than or equal to 15. This tells us the total cost cannot be more than £15. Now, let's put the problem-solving steps in the correct order. The steps are: solve the equation using inverse operations. Identify the unknown and assign a variable such as x. Check whether the answer makes sense in the context of the story. Translate the words into an algebraic equation or inequality. Pause the video and decide which step should come first, second, third, and fourth. The correct order is: first, identify the unknown and assign a variable. Second, translate the words into an algebraic equation or inequality. Third, solve the equation using inverse operations. Fourth, check if the answer makes sense in the context of the story. This final step is important because GCSE questions often include real-life contexts where some answers may not make sense. For example, if the answer represents people, you usually cannot have a decimal number of people. Let's finish with an exam strategy question. A common GCSE question asks you to rearrange a formula where the subject is in the denominator. For example, f equals 1 over a plus 1 over b. What is the most dangerous mistake a student could make here? Pause the video and think carefully. The danger is treating the terms as if you can simply flip them individually. Algebraic fractions must be handled carefully. You might have said that one dangerous mistake is trying to flip individual terms. For example, you cannot say that if f equals 1 over a plus 1 over b, then 1 over f equals a plus b. That does not work. Another common mistake is forgetting to multiply every term by the common denominator. Students may also forget to factorize if the subject appears in multiple terms. A safer strategy is to clear denominators first. That turns the formula into something more like a linear equation, which is much easier to rearrange. Let's summarize the main techniques from today's lesson. For fraction clearing, multiply by the lowest common multiple to remove denominators. For subject isolation, use inverse operations to get the target variable on its own. For worded translation, identify the unknown, assign a variable, and build the equation or inequality step by step. These techniques are powerful because they help you handle more complex GCSE algebra questions with confidence. You should now be able to clear denominators, rearrange formulae, deal with subjects that appear more than once, and translate worded problems into algebra. Remember, complex algebra is just a sequence of simple steps done carefully. If this lesson helped, please like the video, subscribe to Mind to Your Learning, and watch the next GCSE Maths lesson to keep building your algebra confidence.